We all know that the vertical line is y-axis. This can be named as y dash. Horizontal line let it be x dash. The point of intersection of x-axis and y-axis is origin. Let it be O. These are the points. Let them be 1, 2, 3, 4, so on. To the right side. -1, -2, -3, -4 to the left side. And above the origin we have positive again. 1, 2, 3, 4. Let it be up to 5. And again below the origin also we have negative -1, -2, -3, -4, so on. So we found that to the right side of origin we have positive values and above also positive. So both will be like plus plus. That means the point will be represented both as positive. Because we have positive axis to the right side of origin and positive above the origin. Similarly, this can be named as quadrant 1. And first one can be called as abscissa, or we can say that x coordinate. And the second one can be called as ordinate or y coordinate. When we come to second quadrant, we have to the left side of origin negative and above positive. So the point will be of the form minus plus. When we come to third quadrant, to the left side of origin we have negative and below also we have negative. So point will be minus minus. When we come to fourth quadrant, the point, how can it be? X-axis to the right side of origin it is plus and below origin it is minus. So it is plus minus. Easily you can remember like this. Suppose I want to plot 1, 2. Where it lies? Means it lies in first quadrant because both are positive. 1 we have to take from x-axis, 2 we have to take from y-axis. So the point can be named here as 1, 2. When we want to plot -1, 2, where it lies? In second quadrant. -1 will be taken from x-axis, 2 will be taken from y-axis. The point can be written -1, 2 here. And -1, -2 where it lies? Definitely in the third quadrant. Both are negative. -1 will be taken from x-axis, -2 will be taken from y-axis. So -1, -2 lies here. And the fourth quadrant, how will it be? 1, -2. 1 will be taken from x-axis, -2 from y-axis. So the point will be here. Now let us discuss a problem related to coordinate geometry. If Q01 is equidistant from P 5 - 3 and R x 6, find the values of x. Also find the distances QR and PR. So first the clue is given that Q is equidistant from P and Q. So we can easily say that what is given in the question? PQ is equal to QR because Q is equidistant from P and R. If P is this and R is this, Q is equidistant from P and R. So PQ will be equal to QR. Already we know distance between 2 points P and Q the formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square, or we can take x1 minus x2 whole square plus y1 minus y2 whole square, because anyhow square is there. Minus value square or plus value square, same answer will be given for both. So we can consider neither of these. So here also we have QR. What do we have? Same, under root of x2 minus x1 whole square plus y2 minus y1 whole square. So both the sides we have roots. Either we can square on both sides to get rid of this square, or we can cancel the roots. So we can square on both sides and we can apply the values. Here let us take P 5 minus 3 and Q 0 1. So let us find the distance here by cancelling the root, because we are squaring. Square and root gets cancelled. So let us take directly. This is x1 y1 and x2 y2 here. x2 minus x1. So 0 minus 5 whole square plus 1 minus of plus 3 whole square. Here what can we consider? Q 0 1, it is x1 y1, and R x6, it is x2 y2. So we can write it as x2 minus x1. So x minus 0, anyhow it is x whole square plus 6 minus 1 whole square by 2 minus 1 whole square. Now what happens? Minus 5 whole square is nothing but 25. 1 plus 3, 4. 4 square is 16. X minus 0 is x anyhow, x square. 6 minus 1, 5 square. It is anyhow 25. So we can write directly 25. Now both the sides we have 25, we can cancel. Now square becomes 16 and x becomes root 16, which is equivalent to plus or minus 4. So we will consider x values as 4 one time and another time minus 4. So both are the values of x. One question is completed. Now we need to find the distances of QR and PR by replacing x by 4 one time and x as minus 4 another time. So let us find the distance QR. Let us write Q as what? We have already known that it is 0, 1. And what is R? Just now we have found it as 4 or minus 4. So x can be replaced by 4 and written as 4, 6. So let us find the distance of QR, that is under root of x2 minus x1 whole square and y2 minus y1 whole square. So let us name these as x1 y1 and x2 y2. 4 minus 0 whole square plus 6 minus 1 whole square. So under root of 4 square is 16 and 6 minus 1 5 square is as 25. So we have, what do we get? 41. Root 41 is the distance of QR. And what about PR? We can even find out by taking minus 4 also. We get the same answer because minus 4 whole square is also 16. In place of x, minus 4 also can be replaced. Now let us find PR. Here P is what? Already we know that it is 5 minus 3. We will take as x1 y1. R we have found out x value, let it be 4 and 6. Now let us find the distance PR, that is under root of x2 minus x1 whole square and y2 minus y1 whole square. So 4 minus 5 whole square plus 6 plus 3 whole square, that is 4 minus 5 is minus 1 whole square, 6 plus 3 is 9 square. So under root of 1 plus 81, 9 square is 81, so it is under root of 82.